Next example, 2.12. The period of oscillation of a simple pendulum, that is T equal to 2 pi under root L by G. Measured value of L, that is 20 centimeter, known to 1 millimeter accuracy, and time for 100 oscillations of the pendulum is found to be 90 seconds using a wristwatch of 1 second resolution. What is the accuracy in determination of G? Measured value of L is 20 centimeter, known to 1 millimeter accuracy. It implies that the length is measured with the help of instrument for which the measurement that can be taken with 1 millimeter accuracy means the least count of that particular instrument, that is 1 millimeter. So the possible error appear in the measurement, that is equal to 1 millimeter. Similarly, when we say the time is measured with the wristwatch of 1 second resolution, it implies that the least count of wristwatch, that is 1 second. So again here we can say the possible error in the measurement, that is 1 second. So when these words are used, then you can consider these measurements as the absolute error appearing in your measurement. Clear to all of you? Now see, measured value of L is 20 centimeter, known to 1 millimeter accuracy. So 1 millimeter can be treated as its absolute error. 1 millimeter, that is 0.1 centimeter. So we can represent the length L of the pendulum equal to 20 centimeter, that is the true value of the measurement, plus or minus 0.1 centimeter, that is the absolute error in that measurement. Then after, you measure the time for 100 oscillations. So number of oscillations under consideration, that is n equal to 100. And time for 100 oscillations t, that is equal to 90 seconds. Clear? Now see, here the equation for the period of oscillation that is given to you, t equal to 2 pi under root L by G. But we want accuracy in determination of G. So first of all, here we have to make G as a subject of equation. So take square on both the side. So we can write t square equal to 4 pi square into L by G. Therefore, G equal to 4 pi square L upon t square. Now, we discussed about the combination of errors. So here, say G, that is equal to 4 pi square. But this 4 pi square, that is constant. And there is no error in the constant. So now, error in the constant is 0. So no need to consider it. Now L upon t square. So here division of quantities appears. It implies that the relative error in G, that will be equal to the relative error, summation of the relative errors in individual physical quantities. So delta G by G equal to delta L by L plus delta T by T. But in equation, T is appearing with power 2. So we have to multiply the relative error in t with 2. So finally we can write delta G by G equal to delta L by L plus 2 times delta T by T. Clear to all of you? Now we have time for n oscillations, that is equal to small t second. Therefore, time of one oscillation, that is how much? So here the relationship between capital T and small t, that is established. So capital T, that is equal to small t by n. So in terms of variation, we can write the same equation as delta T equal to delta small t by n. There is no variation in n because n is just a number. Okay. Now, if we take the ratio of these two equations, then delta T by T, that is equal to delta small t by n divided by small t by n. It implies that the relative error in periodic time capital T, that is equal to the relative error in the total measured time t. Now, substitute this particular value in this equation. So delta G by G equal to delta L by L plus 2 times delta small t upon small t. Now, substitute the values. Delta G by G equal to, now delta L, that is 0.1, L, that is 22, then delta T, the error in the measurement of the total time, that is 1 second, and total time measured, that is 90 seconds. So when you solve this one, your answer will come to 0.027. So after rounding off this one, you can write 0.03. Therefore, percentage error, that is delta G by G into 100. So that is 0.03 into 100. So percentage error in the measurement of acceleration due to gravity, that is 3%. Clear to all of you?